Hello everyone, welcome to Vyas Edification Kota. In this session, we are going to discuss NCERT and exercise solution of class 12, chapter number 7, alternating current. Clear? So, we are going to discuss detailed solution or detailed discussion of each and every question. Definitely you will understand here theory also with the help of questions. Clear? So now we are going to discuss each and every question. So for the solution of all the questions, concentrate on a screen. So dear student, we are going to discuss this question number 7.1, and in this question it is given to you a 100 ohm resistor is connected to a 220 volt 50 hertz AC supply. Clear? So my dear student, whenever you will find any question that is related to AC, first of all always try to draw here a circuit diagram. Clear? So that you will get some clarity of question. Clear? So now first we are going to discuss here. In this question it is given to you a 100 ohm resistor is connected to a 220 volt 50 hertz AC supply. So I can say, let's suppose this is resistor. Clear? Value of this resistance, it is given to you 100 ohm. Clear? It is connected with a AC supply and it is given to you 220 volt and frequency is given 50 hertz. Okay, fine. Now what is my first objective in this question? What is RMS value of current in this circuit? Clear? So how can we calculate RMS current? For RMS, always keep in mind, in alternating current we always find, whenever it is not mentioned peak current or peak voltage, we always find here RMS current or RMS voltage. Clear? So now here we can see IRMS. Clear? IRMS, this is given by, I can say VRMS divided by total impedance of a circuit, but in this circuit we have only resistance, so I can say total resistance of this circuit we have, that is R. Clear? Now this 220 volt that is given to you, this is RMS voltage. Clear? RMS means root means square voltage. Clear? So from here you can write like this: IRMS, this is equal to VRMS. VRMS is given 220 volt divided by resistance. Resistance value is given to you, this is 100. So from here you can say we are getting value 2.2 ampere. Clear? So this is value of RMS value of current in this circuit. Clear? Now we are going to discuss part number B. Clear? In part number B, it is given to you what is the net power consumed over a full cycle. Clear? So net power consumed. So it means net power consumed means we always find here average power, and average power it may be written like this. This is VRMS multiply IRMS. Clear? VRMS is given to you. Yes, this is 220 and multiplied with IRMS. IRMS, this is equal to 2.2. From here we can say this is 10, this one and this one cancelled out, and I can say that is 484, and we can say, because this is power, I can say that is watt. Clear? So I can say average power we are getting 484 watt. Clear? So this is all about this question. Now dear student, we are going to discuss this question number 7.2, and in this question actually we have two parts, part number A and part number B. In this question it is given to you the peak voltage of an AC supply is 300 volt. What is RMS voltage? Clear? So now in this question number A, it is given to you the peak voltage of an AC supply is 300 volt. So I can say V0, this is given to you 300 volt. Clear? This is given in a question. Now we have to find what is RMS voltage. So our objective is to calculate VRMS. Clear? Do you know what is relation between RMS voltage and peak voltage? Yes, actually we know one relation. VRMS, this is given by V by under root 2. Clear? So V0 is what? This is peak voltage and it is given in a question 300 divided by under root 2. Clear? So from here we can write like this: 300 1.414. Clear? And if you divide here 1 upon 1.414, definitely you will find this value 0.707 into 300. Clear? From here if you remove this one, you can say 1010, this one is cancelled out. Clear? And from here you can see, if you multiply, we can say this is 21, and again we can say that is 21 divided by 10. clear. So we are getting here 212.1, clear, and this is volt, clear. So this is value of RMS voltage, clear to everyone. Now we are going to discuss part number B, and in part number B it is given to you RMS value of current in an AC circuit is 10 ampere, clear. So I can say IRMS, and this value we have 10 ampere. Now what is value P current? Now actually we have same relation between RMS, either we are talking about voltage or we are talking about current. So I can write like this IRMS, that is given by I naught by root 2, clear. My objective is what? My objective is calculate I naught. So I can say I naught, this is given by under root 2 IRMS, clear. So under root 2 means 1.414 multiply IRMS. IRMS equal to what? That is 10. So I can say 14.14, this is ampere, clear. So now we can say value of P current we are getting 14.14 ampere, clear. So this is all about this question. Now we are going to discuss question number 7.3, and in this question it is given to you a 44 millihenry inductor is connected to a 220 volt 50 hertz AC supply. Determine the RMS value of current in a circuit, clear. So now consider. Now it is given in this question. Let's suppose I am saying this is an inductor, clear, and this inductor is connected to an AC supply. This is AC supply, clear, and it is given this is 220 volt and I can say this is 50 hertz, clear. So 220 volt and 50 hertz, this is given to you. Now and one more thing is given, that is capital L, and this value is given to you 44 millihenry, clear. This is value of inductance, clear. So now our objective in this question is to calculate RMS value of current, clear. So how can we write? We can write like this IRMS, this is given by VRMS divided by impedance of this circuit. Now impedance means definitely here I will write the resistance that is offered by this inductor, clear, and definitely you know it is denoted by XL, clear, clear. So now we can say VRMS. VRMS is already given to you in this question, this is 220 volt, clear. But what about XL? What about XL? So I can say XL, this is given by omega L, clear. XL that is given by omega L, and omega, do you know that is equal to what? 2 pi f, clear. So first can we calculate here value of XL? Yes. So XL value is calculated by omega L, clear. Omega we can write like this is 2 pi fL, clear. So 2 multiply pi multiply frequency. Frequency in this question given 50 hertz, and what about inductance? That is capital L. So 44 millihenry. So I can say this is 10 to the power minus 3, clear. From here you can say 2 multiply 50, 100, and this is 10 to the power minus 3. So I can say this is 44 pi multiply, I can say because this is 100, so 10 to the power minus 1, clear. So can we write like this? This is equal to 45 pi into 10, and I can 10 to the power minus 1 ohm, clear, because this is representing impedance or we can say resistance of a circuit. Now can we write like this IRMS, this is equal to VRMS. VRMS is given in this question, this is 220 volt divided by I can say 44 pi multiply 10 to the power minus 1, clear. So from here you can write like this, this is 220 multiply 10 divided by 44 into 3.14, clear. So how can we solve it? Actually we can write like this, instead of 3.14 you can say you can write 22 by 7, so that calculation become comparatively easy, clear. So I can say this is equal to 22 by 7. Now you can say this is equal to 10, clear. So we can say this is equal to 100 multiply 7 divided by 44, clear. Now we can say approximately if we calculate here 7 6 times, that is 42. So approximately I am saying this is approximately 6, clear. So approximately you can say this is 100 divided by 6. So we can say this is equal to 50 by 3, clear. And from here you can say this is near about 16, clear, near about 16, and we are getting value in ampere, clear. So definitely you can say here you will get some value 6 point something, clear, and here you will get value of current that is just below 16 ampere, clear. So near about 15.9 or 15.8 ampere you will get, clear. So this is all about this question, clear to everyone. Now we are going to discuss question number 7.4, and in this question it is given to you a 60 microfarad capacitor is connected to a 110 volt and 60 Hz AC supply. Determine the RMS value of current in this circuit, clear. So now here it is given to you. Let's suppose we can say this is capacitor, clear. This is value, this is capacitor, and this capacitor is connected with an AC supply, clear, and value of AC supply is given 110 volt and this is 60 Hz, clear. Now value of capacitance, this is provided to you, this is 60 microfarad, clear. Now my objective here in this question is to calculate value of RMS, clear, that is IRMS. So I can say IRMS, this is given by one formula, VRMS divided by total impedance of this circuit. Now in this circuit we have only capacitor, so we can write like this, this is equal to VRMS and divided by, I can say that is XC, clear. So now first we will calculate here value of XC. Value of XC, this is given by 1 upon omega C, 1 upon omega C, 1 upon omega C, and we can say this is equal to 2 pi f and this is C, clear. So now if I put here all the values, I can say this is 2 into 22 by 7 multiply frequency. Frequency is given 60 Hz and capacitance is given to you 60 microfarad. Micro means 10 to the power minus 6, clear. So from here we can write like this, value of XC, this is given by 1 upon, I can say 44 divided by 7 multiply 60 into 60 into 10 to the power minus 6, clear. Now I can say here what is value of IRMS, clear, IRMS. So I can say IRMS, this is given by VRMS upon XC. So VRMS is given to you, this is 110, clear, and it is divided by XC. XC is given to you, this is you can solve it here, so it will be better for us. So 10 to the power 6 divided by 44 multiply 7, and we can say multiply 6 into 6, clear, into 10 to the power 2, clear. We can write like this. So from here you can say this is 10 to the power 4, clear. Approximately I am taking this is 6 times, clear. So now we can say this is 1 upon 6 cube, near about. So near about I can say this is 10 to the power 4 and 216, clear. Now let's suppose I am taking this as 2 to 5, near about. So 2 to 5, clear. So 2 to 5 if you take it, and let's suppose I am taking here 1000 and this is 10, clear, and approximately I am saying, I know this is there is a difference between 216 and 2 to 5, but if we calculate here you will find 2 to 5 divided by 1000 divided by 2 to 5, that is equal to what? 2 to 5 multiply 2, clear. Or you can say you can write like this, it will be better to you. If I say here this is 120 divided by, or we can say this is near about 220, okay. So what we are doing here, actually I am taking this is 216, can I write like this, this is equal to near about 216. So we can take here one factor like this so that it will be completely cancelled out. So what I can do here, I can take here this is 2 multiply 125, can I write, no, 2 multiply, just a minute. So can we write here this is 215, clear, or near about you can take it 220, it will be better for you. So I am taking here this is 220, clear, 220. So from here you can say this one and this one cancelled out, and near about you are getting this value 22, 22 we can say that is 488, we have 12 left, and again we can say that is near about 5. So we are taking here this value 45 ohm, clear, approximately value we are getting 45 ohm, this is value of XC. Now we can put this value XC here, this is 45, clear. From here you can say if you divide it, you can say 2 times, we have 90, 20 left, and after that when 20 left, or you can first cancel by 9, 5. So I can say this is 5, 5, 9, and we can say this is 2, clear. 5 to 10 we have this is 2. So 22 by 9. 22 by 9 equal to what? 9 multiplied to 18. We have 4 left, and I can see 4 left. So 3, 4. So 2.4 ampere. Clear? So near about 2.4 ampere you will find here IRMS. Clear? So what is concept in this question? Concept is very simple. First we calculate here value of XC. XC is given by 1 upon omega C. Omega C can be written as 1 upon 2 pi FC, and you can calculate it like this. Clear? Definitely you have to take some approximation here, and near about value you will get that this is equal to 2.4 ampere. Clear? So this is all about this question. Now we are going to discuss question number 7.5, and in this question it is given to you in exercise 7.3 and 7.4. In exercise 7.3 and 7.4, what is the net power absorbed by each circuit over a complete cycle? Explain your answer. Okay, fine. Now you can say in example number 7.3 and 7.4, we have seen these circuits are either purely capacitive circuit or purely inductive circuit. Clear? So now if we draw here a phasor diagram, so you can see for inductor you can see we can take here, this is the direction of voltage or potential difference across resistor. In this direction you will find current. Clear? So if we are talking about inductive circuit, so for inductive circuit actually we have voltage in this direction. Clear? And you can see phase difference between current and voltage, this is 90 degree. Clear? Or you can say for an inductive circuit, current is actually, we can say, lagging behind 90 degree. Clear? So we can say phase difference between them we are getting, that is pi by 2. Clear? So we can write here average power. Average power, this is given by Vrms, I can say IRMS, and value of cos phi. Cos phi we have, this is pi by 2. Clear? So cos pi by 2 means we can say cos 90. Cos 90 equal to what? 0. So I can say this is 0. Clear to you? But what about capacitive circuit? For capacitive circuit, yes, if I am talking about capacitive circuit, now in capacitive circuit what happened? Now let's suppose if I am saying in this direction we have current. Clear? And definitely we find here voltage across, or we can say potential difference across capacitor in this direction. Again you can say here you will find phase difference between current and voltage, that is 90 degree. Or you can say in purely capacitive circuit, current is leading by voltage by 90 degree. Clear? So again you can say here we are having phase difference, this is equal to pi by 2. Clear? So now we can find here average power. So P average, this P average is given by Vrms, I can say that is IRMS, and this is equal to cos of pi by 2. Clear? Cos pi by 2 equal to what? This is 0. So again we are saying here we are getting 0 volt. Clear? So either we are having purely capacitive circuit or purely inductive circuit. At the time you will find average power, that is equal to 0, because phase difference we are having 90 degree. Clear? So this is all about this question. Now student, we are going to discuss question number 7.6, and in this question it is given to you, obtain the resonant frequency omega r of series LCR circuit. Clear? And it is given L value, C value and R value. Now what is value of Q value of this circuit? Clear? So first of all let's draw here this LCR, series LCR circuit. I can say, let's suppose this is inductor L, here we have capacitor, and I can say here we have resistance R. Clear? Values are also given to you. This is twice Henry. I can say C equal to 32 microfarad. Clear? Value of R, this is given to you 10 ohm. Clear? It is connected with a AC source. Clear? So let's suppose it is connected with an AC source. Clear? Now we have to find resonant frequency. First of all, let us try to understand what is resonant frequency. Resonant frequency you will find when frequency of this circuit is equal to natural frequency. Clear? So it means I can say for resonant frequency, what is condition? resonant frequency. Actually, what is meaning of resonant frequency? Resonant frequency means we can say we are getting here maximum value of current. Clear? So, if we talk about IRMS, this is written like this, VRMS divided by Z. Clear? And for an LCR circuit, you can say value of Z, this is given by under root of R square plus XL minus XC whole square. Clear? Now, if you draw here phasor diagram, you can say, let's suppose I am saying this is impedance triangle. Clear? Let's suppose this is representing R. Clear? In this direction we have XL. Clear? In this direction we have XC. I am assuming here that XL is greater than XC. So at that time you can say net value you will get here in this direction, that is XL minus XC. Clear? And definitely you will get resultant in this direction, and actually this is value of Z. Clear? So you can get here value Z, this is equal to under root of R square plus XL minus XC whole square. Clear to you? So from here you can write like this, this is Z under root of R square plus XL minus XC whole square. Clear? Now what is value of R we have? That is actually what I want to say, because we are talking about resonant frequency. Clear? Resonant frequency means we can say this XL is equal to XC. Clear? For resonant frequency we are getting XL equal to XC, so at that time we are getting just only R square. It means I can say here resistance, this should be equal to R. Clear? What is my objective? My objective here is first calculating this resonant frequency. Clear? So resonant frequency omega R, this is given by we can say under root of LC. Now you can say from where we are getting this value. So you know, you already told me, sir, XL equal to XC. Clear? XL is given by this is omega L, and we can say this is equal to omega C. Clear? So from here you can write like this, omega square, this is equal to 1 upon LC. Clear? So omega we can say this is equal to 1 upon under root of LC. So actually this omega is what? This is resonant frequency. Clear? So now concentrate. Now we are going to put here all values. Clear? Yes. Now you can say we know here formula of resonant frequency. Resonant frequency is given by this is given by 1 upon under root of LC. Clear? Now what is value of L? We have 2, and what about C? That is 32 microfarad. So we can write like this, 1 upon under root of, I can say this is 2 multiply C, I can say this is 32 into 10 to the power minus 6. Clear? So from here we can write like this, omega R is given by 1 upon under root of 64 into 10 to the power minus 6. Clear? So I can say this can be written like this, this is 10 to the power 3 divided by, I can say that is 8. Clear? So from here you can see resonant frequency, this is given by 125 radian per second. Clear to everyone? Now next objective here in this question is to calculate value of Q value. So Q value is actually given by one formula, omega R L by R. Clear? Omega R L by R. Clear? So from where we are getting, there is a derivation behind this expression. You can go through with NCERT as well, you can go through with any reference. Clear? So Q is given by omega R L by R. Omega R we have, this is 125 multiply L by R. L is given to you, yes, this is equal to 2 Henry, and divided by value of R. R value we are getting, this is 10. Clear? So we can say this is 250 divided by 10, this is equal to 25. Clear? Yes or no? So we are getting here this Q value. Now you can say, sir, what this Q value indicate? Actually this Q value indicate the sharpness of a curve, because at resonance frequency we are getting maximum voltage. Clear? So actually we can say if you find here that Q value actually indicates sharpness of a curve. Clear? So this is all about this question. Clear? Now student, we are going to discuss question number 7.7, and in this question it is given to you a charged 30 microfarad capacitor is connected to a 27 millihenry inductor. Find what is angular frequency of free oscillations of circuit. Clear? So my dear student, this is a question related to LC oscillations. So now you can see in this question it is given, let's suppose this is inductor and it is connected here with a capacitor like this. Clear? Value of L, value of C, it is given to you 30 microfarad, and inductance value, it is given to you 27 millihenry. Fine. What is angular frequency of free oscillation of circuit? So because this is a case of LC oscillation, and in LC oscillation we know omega, this is given by 1 upon under root of LC. Clear? So from here I can write like this, 1 upon under root of L. Clear? L is given to you 27 millihenry, so 27 into 10 to the power minus 3 multiply, what about C? C is given 30 into 10 to the power minus 6. Clear? So from here I can write like this, this is equal to 1 upon under root of 27 multiply 30, this is 10 to the power minus 1 I am saying, and we have 10 to the power minus 8 also. So if you take square root, we can say this is 10 to the power 4. Clear? Now you can say this one and this one cancelled out, and from here I can say this is 10 to the power 4 divided by 81. 81 means I am saying this is 9. Yes or no? 81 square root of 81, this is 9. So this is equal to 10 divided by 9 into 10 to the power 3, and I can say this is radian per second. Clear? So from here I am saying this is equal to 1.1 into 10 to the power 3 radian per second. Clear? So this is all about this question. Clear? Now dear student, we are going to discuss this question number 7.8, and in this question it is given to you, suppose the initial charge on the capacitor in exercise 7.7 is 6 millicoulomb. Find what is the total energy stored in circuit initially and what is total energy at later time. Clear? So now we can see here this is inductor, and let's suppose I can say this is capacitor. Clear? It is given in this question, initial charge stored, this is given to you 6 millicoulomb. Clear? Okay. Now what is initial energy stored? I can say this is given by Q naught square divided by 2C. This formula you know very well. Clear? Value of Q naught, I can say this is 6 into 10 to the power minus 3 multiply 6 into 10 to the power minus 3 divided by. Now what is value of capacitance? So if you see previous question, you can say here 30 microfarad capacitance we have. So I can write like this, 2 into 30 into 10 to the power minus 6. We can say this one and this one cancelled out. Clear? And I can say this one is 5. Yes. So from here you can say initial energy, this is given by 0.6 joule. Clear? 0.6 joule. Clear? This is initial energy. Clear? Now it is asking to you what is total energy at later time. Now what will happen? Initially when capacitor is fully charged, definitely here the charge will flow in this direction. Clear? And actually some of electric energy at particular instant, some of electric energy is converting into this magnetic energy. Clear? And definitely you can see here energy stored in a form of half of Li square. Clear? After some time, when this capacitor is fully discharged, all the total energy it is due to this magnetic energy, or we can say half of Li square. After that again there is a conversion of this magnetic energy into electrical energy. So actually you will find here oscillation of charges, and you will find that each time whenever we are discussing about, if we are taking total as a system, we can say some of energy is shared by capacitor, some of its energy is shared by inductor. Clear? But if I am talking about total energy of system always remains same. Clear? So I can say if we have initial energy 0.6 joule. Clear? You can say, sir, what about energy initially in inductor? That is 0, because the charge is not flowing. So when charge will flow at the time, let's suppose 0.3 joule energy having in a capacitor, so 0.3 joule of energy it is stored by inductor. Clear? So like this we can say total energy of this circuit that always remain same. Clear? So correct answer we have total energy total energy at any time, you can say this is always equal to 0.6 joule. Yes, we never say that there is an equal distribution of energy in capacitor and inductor. Clear? Definitely sometimes the capacitor energy will be more, and we can say this half of Li square, that energy is less. Clear? Sometimes it may be possible this energy will be more and this one is less, but total amount of energy always remain same. Clear? So this is all about this question. Now student, we are going to discuss this question number 7.9, and in this question it is given to you a series LCR circuit with R equal to 20 ohm and L equal to 1.5 Henry and C equal to 35 microfarad is connected to a variable frequency 200 volt AC supply. Clear? So now you can see, let's suppose here we are having this is inductor, let's suppose here we are having capacitor, and let's suppose this is resistance. Clear? And it is connected with an AC source, this is AC source. Clear? Now it is also given value of L, this value of L we have 1.5 Henry. Clear? If I am talking about capacitance, capacitance is given by 35 microfarad. Clear? And what about resistance? Resistance is given to you, this is 20 ohm. Clear? And we are supplying here 200 volt. Clear? So now we can say when frequency of supply equals natural frequency of circuit. So when frequency of supply, it means let's suppose you are saying 200 volt 50 hertz. So when frequency of supply that is equal to frequency of this circuit, at that time we can say we will always find resonance condition. Clear? And in resonance condition you know very well XL is equal to XC. Clear? XL is equal to XC. So from there we can see total impedance of this circuit that is equal to R only. Clear? Total impedance of the circuit is equal to R. From where we are getting, actually we know value of Z, that is given by R square plus XL minus XC whole square. Clear? In resonance condition XL and XC is same, so I can say Z equal to R. Clear? What is my objective? My objective here is to calculate average power transferred in a circuit. So how can I write average power? So first, can I calculate here IRMS? Yes or no? IRMS we can write like this, this is equal to VRMS and divide by Z. Clear? Or you can also write like this directly. If you do not want to calculate this current, directly you can say actually, yes, we can say average power, this average power, this is given by VRMS square divided by I can say Z. Clear? So we can also write like this VRMS. VRMS we have, this is 200. So 200 multiply 200 divided by I can say Z. Clear? So Z is given to you, this is R. Clear? Now value of R, this is given 20 ohm. Clear? So from here we can say this is 200 into 200 and divided by value of R, this is 20. Clear? So I can say this one and this one cancelled out, I can say that is 10. So from where we are getting this is 2000 watt. Clear? Or I can say this is equal to 2 kilowatt. Clear? So this is all about this question. Now student, we are going to discuss this question, and in this question it is given to you, this is question number 7.10. Question is given to you, a radio can tune over the frequency range of a portion of medium wave broadcast band and 800 kilohertz to 1200 kilohertz. Fine. If an LC circuit has an effective inductance of 200 microhenry, what must be range of its variable capacitor? Clear? Actually one important term is given to you. It is given here because this is a radio. Clear? So in radio we always whenever we change some value, like let's suppose if I am talking about 92.5, 92.7, 94.3 my FM. So if you are actually tuning this radio station, at that time there is one condition, that the frequency of circuit, it should be equal to frequency of source. Clear? It means whenever you find resonance, so in resonance condition, what is value of omega? Omega value is given 1 upon under root of LC. Clear? But here it is given to you, this is frequency and in hertz. So I can say frequency, this is given by 1 upon 2 pi under root of 1 upon LC. Clear? I can say this is equal to what? 1 upon 2 pi multiply 1 upon under root of LC. So frequency we can say this is equal to 1 upon 2 pi and and directly we can say 1 upon under root of LC. Clear to everyone? Clear? So now my objective here is to find value of C. So I can say we can write like this, f square, this is given by 1 upon 4 pi square LC. Clear? So from here can we write here value of C? Yes. I can say this is equal to 1 upon 4 pi square. Clear? I can say that is f square. Clear? And it is multiplied with what? That is L. Clear? Now we know here we are having different frequencies, so we can put here values of all frequency. First I am writing here f1 equal to 800 kilohertz. It means I can write this is equal to 8 into 10 to the power 5 hertz. Clear? So at the time we can say value of C we are getting 1 upon C multiply pi square multiply f square. F square means we can say 8 multiply 8 into 10 to the power 10. Clear? And it is multiplied with I can say capital L. Clear? Capital L is given to you that is 200 micro Henry. Clear? So this is 200 into 10 to the power minus 6. Clear? So from here we can say value of C1, this is given by 1 upon 4 multiply 10 multiply 64 into, I can say this is 2 into 10 to the power minus 4 and 10 to the power 6. Clear? Yes or no? So from here you can say and how can we calculate? This is actually we can say 132 multiply 4. Clear? Or we can say this is 1 upon 132 multiply 4. 132 multiply 4 equal to what? We can say that is 8, 12 and we have 1, 5, 28. Clear? So I can write like this, this is 528 and multiply 10 to the power minus we can say 7. Clear? Clear? Now can I write like this, this is equal to, if I multiply here with 1000 into 1000 means that if I am multiplying here we can say, just a minute, I am multiplying here 10 to the power 5 in denominator and numerator. Clear? Because it is necessary for question. So I can say we can say 10 to the power 5 in numerator and 10 to the power 5 in denominator. Clear? So let's suppose I am assuming this is to be near about 500. Clear? So 1000 divided by 500 near about I am saying. So approximately you can say this value is you are getting near about 2. Clear? Or definitely you will get some less value. So I am saying this is, let's suppose 1.95. Clear? 1.95 and now you can say this is what 1.95. I can say this is 10 to the power 3. Clear? 10 to the power 3. So or you can say actually like this. Okay, no problem. This is equal to 1.95 into 10 to the power minus 10. Clear? And we are getting this value in farad. So can we convert this value in picofarad? Yes. So value of C1 we are getting here 1.95. Clear? Multiplied with 100 and multiplied with 10 to the power minus 12 farad. Clear? So we can say this is value 195 into 10 to the power minus 12. So we can say C1 this is given by 195 picofarad. Clear? So we are getting this value of capacitance for this frequency range. Clear? Now, so now we can say actually can we get here, can we calculate here for the same for the next one? Yes, I am writing this value first here because so that we can say here what about the frequency range, I mean what about capacitance range. Clear? Value of C1 this is equal to 195 picofarad. Clear? Now listen carefully. Now here we will apply same formula. Clear? Same formula but only I just change here about frequency. Clear? Frequency in this question is given to you 12 kilohertz. Clear? So I can say this is equal to 1200 into 10 to the power 3 hertz. So instead of 8 here I will write that is 12. Yes or no? Or you can say if we again do here some calculation, better if we do here calculation again, just a minute. Yes, we can do here again this calculation. So yes, so I think concept is definitely clear to you. What is the concept here? Concept is very simple. Here we will apply this formula and we will get our value. Clear? So Now we can say value of C2. Value of C2, this is given by, I can say 1 upon 4, I can say pi square near about 10, clear, f. I can say this is 12 into 10 to the power 5 into 12 into 10 to the power 5, and what about L? L is given in this question 200 microhenry. So 200 into 10 to the power minus 6, clear. So now from here we can see value of C2. Value of C2 is equal to what? 1 upon, clear, 1 upon, I can say 4 multiply 12, 4 multiply 12 into 10 to the power 6 into 12 into 10 to the power 5, clear, multiply, I can say this is 2 into multiply 10 to the power minus 4, clear. So now we can say this one is what? That is 10, clear. So if you multiply it, I can say this is 10 I am taking here, clear. So 12 multiply 4, I can say 48 multiply, clear. Here we have 12 multiply 2, this is 24 multiply, I can say this is 10 to the power 7, clear. So now from here we can write like this, value of C2, that you are getting 24 into, actually you can write 24 into 24, so we can say that is 576, clear. So directly I am saying this is 2 multiply 576, clear, and this is equal to 10 to the power 7, clear. Now what I am doing here, I am multiplying with 10 to the power 5 and dividing with 10 to the power 5, clear. So I can say 10 to the power 5 divided by 2 into 576 into 10 to the power 12, clear. Now I can break here 10 to the power 5 in 2 terms, clear. I am writing here, instead of 10 to the power 5, this is equal to 1000 multiplied with 100, clear. So now we can see this is equal to what? Near about, yes, definitely I can say this is not 2. So let's suppose this is near about 600. So 600 means we will get here 1.33. So I am saying this is near about 1.3, clear. So we can say this is equal to what? 0.65, clear. So now we can say we are getting here 65 picofarad, clear. So now we can say for a given frequency range we are getting capacitive range that is equal to what? I can say C2 we are getting, this is 65 picofarad. So we are getting range from C1 to C2 to C1, clear. And what is our range? From 65 picofarad to 195 picofarad, clear. So this is all about this question. Now student, we are going to discuss this question. This is question number 7.11, and in this question it is given to you, figure shows a series LCR circuit connected to a variable frequency 230 volt, clear, 230 volt source. It is also given L equal to 5 Henry, C equal to 80 microfarad and R equal to 40 ohm. This is given to you, fine. Now what is our objective in this question? Our objective here in this question is to give answer of these 3 questions A, B and C, clear. So first find here what is question number A. Question number A is given, determine the source frequency which drives the circuit in resonance, clear. So what is our objective? Our objective here is to calculate frequency of a source which drives the circuit in resonance, clear. Now you know, if we talk about resonance condition, listen carefully. In resonance condition, I can see omega, this is given by 1 upon under root of LC, clear. Now do you know what is value of L and C, clear. We can see from here, value of L, that is given to you 5 Henry and C is 80 microfarad. So I can see 5 Henry and this is 80 into 10 to the power minus 6, clear. From here you can say 5 multiply 80, 400. So we are getting in denominator, that is 1 by 20, and I can say this is 10 to the power 3, clear. So now I can say omega is given by what? 10 to the power 3 divided by 20. So I can say this is equal to 50 radian per second, clear. So this is the answer of resonant frequency, clear to you? Yes. Now if we talk about part number B is given to you, obtain the impedance of circuit, clear, and the amplitude of current at resonant frequency, clear. So now we can say, yes, if we are talking about impedance, clear. So at resonance condition, what is value of impedance? We can say at resonance this Z is equal to capital R, clear. In resonance condition we are getting capital Z is equal to capital R, and capital R value, this is given to you in a question, equal to 40 ohm. Clear? So this value we have 40 ohm. Clear? Next our objective here is to find value of current, amplitude of a current, it means maximum current. So maximum current I can say this is given by I naught equal to V naught divided by R. Clear? Why I am writing here R? Because Z is equal to R at resonance condition. Clear? So what is value of V naught? Now in this question VRMS is given to you. Yes, VRMS is given. Yes, 230 volt. So I can say this is 230 multiplied under root 2 and it is divided by R. R is given this one. Clear? So from here we can say this is 23 by 4 and multiply under root 2. Clear? So from here you can say 23 multiply 1.4 and I can say this is multiplied with 4. Clear? So I can say this is equal to 2. We have 9 and I can say 9 means 32.4 and this one. Clear? So near about you are getting this value, this is 8.1. Clear? So maximum current that we are getting in this circuit, this is equal to 8.1 ampere. Clear? Yes. Now what is our next objective? Next objective in this question we have determine the RMS potential drop across 3 element of circuit. Okay. So now we can see RMS. So if we want to find RMS potential drop, it means first we will calculate here IRMS. Clear? IRMS is given by VRMS divided by capital Z. Clear? VRMS is equal to what? I can say that this is given in this question 230 and divided by, we can say that is 40. So we can say current value we are getting 23 by 4 ampere. Clear? Now I can say potential drop across inductor. This is given by IRMS and multiplied with XL. Clear? I value is given to you 23 by 4. I can say this is equal to omega L. Clear? So 23 by 4 multiply omega. Omega is equal to 50 radian per second. And what about L? Clear? Value of L, this is given to you 5 Henry. So I can say this is 5. Clear? So from here we can see if you multiply it, this is 250. So 23 multiply 250 divide by 4. Approximately you can say this is near about 6. Clear? So from here we are getting near about 1500 and we can say volt. Near about. Clear? 1500 volt. Same here, if you find potential drop across capacitor, I can say this is given by IXC. Clear? 23 by 4 multiply 1 upon omega C. Clear? Now you can say 23 by 4 multiply 1 upon omega. Omega is 50 and multiply C. C is given to you. Yes, that is 80 microfarad. So 80 into 10 to the power minus 6. Clear? So now we can say we can write like this: 23 by 4 multiply 1 upon 400. Actually 4000. Clear? And multiply 10 to the power 6. Clear? From here we can say this is equal to what? 10 to the power 3. Near about I can say that is 6. Clear? So we are getting 6 by 4. This is equal to 1.5 and we are getting same answer near about 1500 watt. Clear? Now my objective, what is my objective here in this question? We have to determine, we have to show potential drop across LC combination is 0. Clear? So now we can say if I am talking about potential drop across LC combination, so directly you can say potential drop across LC combination is given by, this is IRMS and I can say XL minus XC. Clear? So because both are in opposite phase, so XL minus XC. Now you can say here directly we can say VL minus VC, this is equal to 0. Yes, because IRMS into XL equal to what? I can say VL and IRMS multiply XC, VC. So I can say potential drop across LC circuit. The potential drop across LC circuit from, let's suppose I am taking here 1 point, this is another point. So potential drop across this end is 0. Clear? Okay. Next question is what? In this question it is given and yes. So we have already shown here that potential drop is 0. Clear? So again this is a very good question. Actually you can find here again the potential drop across R also. Clear? And you will calculate, when you will calculate IRMS into R, let's suppose if I say you can calculate here potential drop, IRMS equal to 23 by 4 multiply R. R is given to you in this question, yes, 40. So you can say you are getting 230 volt, clear, and as this is expected. Input supply voltage we have 230 volt, clear, and here we are getting potential drop across this resistor, this is also 230 volt, clear, and potential drop across combination of L and C, this is equal to 0, clear. So this is all about this question. So now dear student, we are going to discuss question number 7.12, clear. And my dear student, this question is actually conceptual question and definitely a little bit lengthy one, but this question will provide you more concept, clear. So actually concentrate on this question. In this question it is given to you an LC circuit contains a 20 millihenry inductor and a 50 microfarad capacitor with an initial charge of 10 millicoulomb, clear. So first whatever is given to you, first we are drawing that one, an LC circuit given 20 millihenry and 50 microfarad capacitor, clear. So let's suppose if I drawing here, let's suppose I can say this is inductor, clear, and I am saying here we have capacitor, clear, and it is given here value of L we have, this is 20 millihenry, clear, and value of capacitor this is given to you 50 microfarad, clear to you, clear. So 20 millihenry and 50 microfarad, and it is given initial charge on a capacitor that is 10 millicoulomb, clear. So I can write here initial charge means we can see maximum charge that can be stored on a charge, this is given to you 10 millicoulomb, 10 millicoulomb, clear to you, 10 millicoulomb. Now in this question given the resistance of a circuit is negligible, it means we will not add here any element of resistance, clear, and it is also given let the instant the circuit is closed be t equal to 0. अभी just मैंने सर्किट को क्लोज किया है तो क्या होगा बेटा, LC oscillation, yes or no, क्योंकि सीरीज सर्किट में केवल कैपेसिटर है and we can say we have only inductance and we have only capacitor, clear. So definitely here we will find some oscillation in between capacitor and inductor, clear to you. So now we can say part number A, it is given to you what is the total energy stored initially, clear, and is it conserved during LC oscillation, clear. So now concentrate here, just a minute. Yes, first of all our objective here is to find total energy stored in a capacitor. So I can say, let's suppose here I am saying, let's suppose this is part A, initial energy stored, it is given by Q naught square divided by 2C, clear. Value of Q naught we have, this is 10 millicoulomb, so I can say this is 10 to the power minus 2, yes or no, 10 into 10 to the power minus 3, so this is 10 to the power minus 2 whole square divided by I can say 250 into 10 to the power minus 6, clear. So from here we can find initial energy stored in a capacitor 10 to the power minus 4 divided by I can say this is 100, we can see this one is 100 multiply 10 to the power minus 6, clear. From here you can see when this 10 to the power minus 6 goes to numerator, it becomes 10 to the power 2, and finally we are getting initial energy stored, this is equal to 1 joule, clear to everyone. So this is answer of part number A. Now in second part it is given to you, yes, actually we have one more thing, is it conserved during LC oscillation? Yes. Actually initially all the charge is stored on the plates of a capacitor, clear. As we connect inductor, some charge will flow from capacitor and it is actually stored as a magnetic energy in an inductor, clear. So definitely some of energy of capacitor is shared with the inductor, clear. But if I am talking about total energy of this system, so total energy, or we can say sum of we can say electrostatic energy and magnetic energy, that total sum always remains constant, clear. So now we can say here, so we can say total amount of energy always remains, this is equal to 1 joule, clear to everyone? Yes. So this is all about part number A. Now if I talk about part number B, what is the natural frequency of this circuit, clear. Now you can say this is LC oscillation, so how can we find here natural frequency? Natural frequency is given by omega equal to 1 upon under root of LC. Clear? So from here we can write like this. This is 1 divided by under root of L. L is given to you, yes, 20 millihenry. So 20 into 10 to the power minus 3 multiply C. C is given to you 50 microfarad. So 50 into 10 to the power minus 6. Clear? So from here I can write like this. Value of omega, this is given by we can say 20 multiply 50, this is 1000 and this one is cancelled out, and finally this is 10 to the power minus 6. So I can say we can write like this is equal to 10 to the power minus 3. Clear? So from here you can write like this. Omega may be written like this 2 pi f, and this is equal to 1 upon 10 to the power minus 3. Clear? Or we can write like this. F, this should be given by 1000 divide by 2 pi. We can say pi value we have 3.14. Clear? So from here we can see value of f, this is 1000 divided by 6.28. Clear? Now approximately I am taking this is equal to 6. Definitely this value is more than 6. I can say this is, you can take 6.25 also. Clear? But I am taking here, let's suppose 6. So if I am taking it 6, then we can say near about we are getting this is 500 divided by 3. Clear? And from here you can say here you will get 166 point something. But so here you are getting this value almost 166.6 hertz. Clear? But now you can say actually here we are having value 6.28. It means definitely I can say here we will find this frequency that is less than 166, or if you exactly calculate here you will find this value is very close to 160 hertz. Clear? So I can say natural frequency of this circuit, it is given by 160 hertz. Clear to everyone? Yes. Now we can say what is part number C. Clear? So now I think part number A and B is clear to you. Yes. Now we are going to discuss at what time is energy stored completely electrical first and completely magnetic. Clear? So now concentrate. Now I am just actually now we are going to discuss part number 3. Clear? Part number 3 is given to you at what time the energy stored is completely electrical, number 1, and completely magnetic. Clear? So concentrate on a screen. Let's suppose here I am saying, let's suppose this is inductor. Clear? And let's suppose I am having here this capacitor. Let's suppose all the energy stored that is completely electrical. It means I can say all the charges that is present on a capacitor. So I am telling here this is plus minus Q naught. Yes or no? Charge that is present on this capacitor Q, this is equal to plus minus Q naught. Clear? So now we can say when we are talking about LC oscillation, the expression of charge that is flowing in NC oscillation, this is given by one expression Q equal to Q naught cos of, I can say, omega t. Clear to everyone? Q equal to Q naught cos of omega t. So it is also given here all the energy that is stored is electrical energy. Electrical energy means we are talking first about part number 1. Electrical energy means I can say this value Q, it is equal to plus minus Q naught. So plus minus Q naught, this is equal to Q naught and cos of omega t. Clear? So from here I can write like this, plus minus Q naught, this is equal to Q naught cos of, I can say this is 2 pi by t and multiplied with t. Clear? So now we can say here this Q naught and Q naught, this one cancel out. So we can write like this, this is cos of 2 pi by t multiply t, this is equal to plus minus 1. Clear? Or we can also write like this, this is cos of 2 pi by t multiply t, this is equal to plus minus, I can say this is cos 0. Clear? Now we can say here we can write this is cos 0, it may be we can say cos pi, yes or no? We can say this is a cos 2 pi. Clear? So from here we can write here this value like this, cos of 2 pi by t multiply t, this should be equal to, I can say this is equal to cos of n pi. Clear? You can place here value of n 0, 1, 2, 3 and so on. Clear? So from here we can say 2 pi by t multiply t, this is given by n pi. Clear? We can say pi and pi, this one is cancelled out. Clear? So from here we can write like this, value of t, this is given by nt by 2. Clear? Now if I place here n equal to 0, at the time I am getting t equal to t equal to 0. Clear? T equal to 0. So t equal to 0. Clear? Now when I am placing here n equal to 1, I am getting here t, this is equal to t by 2. Clear? If I am placing here n equal to 2, I am getting here t, this is equal to t. Clear? Similarly you can say when I am saying n equal to 3, t is given by 3t by 2. Clear to you? So you can say here we will find at time t equal to 0, because it is given initially all charge present in a capacitor. So I can say all energy this is stored is electrical energy. Clear? But if I am talking about t by 2, means after half of cycle, again all charge is stored on a capacitor, and again we have energy that is electrical. After t by 2 more, we can say at time t, I can say again charge stored is only on capacitor. So I can say we have only energy that is related energy, and that is only electrical energy. Clear? So this is all about part number first. Clear to everyone? Now if I am talking about part number second, clear? In part number second it is given, now we have to find time at which all energy that is stored is magnetic energy. Clear? So magnetic energy, now my objective here is to find magnetic energy. So how can we find? We can say whenever all energy is magnetic energy, at that time I can say charge stored in a capacitor, that is 0. Clear? So I can write like this, general expression we have q equal to q naught cos of omega t. Clear? This value of q is 0, so I can say q naught cos of omega t, this is equal to 0. Clear? Now you can say whenever we get this value 0, cos pi by 2, cos 3 pi by 2. Clear? So if I write here generalize, I can say cos 2 pi by t into t, this is equal to cos 2n plus 1, this is pi by 2. Clear? Now if you place value n equal to 0, I can say cos pi by 2. If you place 1, 3 pi by 2, and in all conditions you are getting 0. So from here I can say this is 2 pi by t, this is given by 2n plus 1, and this is pi by 2. Clear? From here you can say pi and pi, this one is cancelled out. So value of t, this is given by 2n plus 1, and that is capital T by 4. Clear? Now if you place n equal to 0, clear? N equal to 0 you will get here, this is t by 4. Clear? It means if let's suppose total time period of this oscillation is capital T, then in 1/4 of a time all the energy that is present here, that is magnetic energy. Clear? Or you can say all electric energy in time 0 to t by 4 is converting into magnetic energy. Clear? Similarly you can say if we have value n equal to 1, n equal to 1 means we can say this is 3, so this is given by 3t by 4. Clear? Let's suppose we are having value n, this is equal to 2, I can say this is given by 5t by 4, I can say this is 7t by 4, and so on. Clear to everyone? So this is the time where you will find all energy stored in LC oscillation in this circuit is only magnetic energy. Clear to everyone? So this is all about part number C. Clear? Yes. Now we can say we have completely solved here part number C. Now we are going to discuss part number D. Clear? So part number D means we can say at what time is the total energy shared equally between inductor and capacitor. Clear? So now concentrate. Yes. Now concentrate. Let's suppose I am taking here, this is inductor, and let's suppose I am saying this is capacitor. Clear? I can say this is C and this is L. It is given in a question that energy stored in a capacitor is half of the total energy stored. Clear? Yes. Question is given to you. At what times is the total energy shared equally between inductor and capacitor? It means what I can say. If we talk about total energy, total initial energy, I can say it is given by Q naught square divided by 2C. You know very well. Let's suppose this is plus, total charge present is Q naught. So Q naught square divided by 2C. But it is given in a question that now this energy is equally distributed in capacitor as well as in this inductor. Clear? So I can say, let's suppose at any instant charge present on this capacitor is Q. So I can say Q square by 2C. This is given by 1 by 2 of total energy present. Clear? Clear? I am assuming here this Q is the charge present at any time t. So we can say this energy is half of total energy. Clear? So from here what we can get, 2C and 2C cancel out. From here we can write like this, this is equal to plus minus Q naught by root 2. Clear? Q is given by what? Q is given by, this is equal to plus minus Q naught by root 2. Clear? Now we can say, we can write like this, Q, this is given by Q naught, I can say that is cos of omega t. Clear? So if I write here value Q, I can say this is equal to plus minus Q naught by root 2, this is given by Q naught, I can say this is cos of omega t. Clear? So from here we can write like this, this Q naught and Q naught, this one is cancelled out. Clear? So from here you can see, we can write like this, cos of omega t, this is equal to, I can say either cos pi by 4 or you can say this is cos 3 pi by 4. Clear? But let's suppose if I generalize this relation, at that time I can write like this, omega t I can say this is 2 pi by t multiply t, this should be equal to, listen carefully how I am writing, n pi plus, clear, what I am saying, n pi, clear, n pi plus, I can say pi by 4 or I can say 3 pi by 4. Clear to you? Clear? You can also write like this, this is plus minus. Clear? So now from here you can write like this, if you take here pi and pi, this one is cancelled out, and from here you can say value of t you are getting, this is t by 2, clear, and plus minus, listen carefully, and plus minus, I can say 1 by 4 or I can say this is 3 by 4. Clear? So from here we can say t, this is given by t by 2. Clear? Now I can say if we take here LCM, clear, or first you can say n plus minus 1 by 4 or 3 by 4. Now you can say, sir, why you are writing? Now we are actually saying here two different times. Clear? So now we can say t can be written as, first I am taking here LCM 4, so 4n plus 4, and I can say this is given by t by 8 and this one is what, 4n plus 1. Clear? I can also say write like this, t2, this is given by, again if you are taking here LCM t by, if you are taking LCM 4, it becomes 4n plus 3. Clear? So like this we can find here two different times. Clear? So now we can say, actually here we will find two times. So let's suppose if you place here n equal to 0, so you are getting here time, we can say first t by 8. Clear? At the time you are getting this is 3t by 8. Clear? If you place 1, now you can say at the time you are getting here 5t by 8. Clear? If you place here 1, you are getting here this is 7t by 8, and we can say if you are placing 2, I can say 9t by 8, and here you are getting 11t by 8. Clear? So we can say these are the times at which you will find energy stored in capacitor on an inductor is half of the total energy present. Clear? So this is again a very good part. Again I am saying this is very conceptual, so very good part. Now we are going to discuss part number D. Part number D is clear to you? Yes. Now we are going to discuss part number E. If a resistor is inserted in the circuit, how much energy is eventually dissipated as heat? Now listen carefully. In LC oscillation, in actually energy is conserved, total energy is conserved because there is no any resistance element is present. But what will happen when resistance is present? So when resistance is present, at that time I can say whenever a charge flow, definitely some of heat will be generated, and slowly I can say total energy is going to be decreased, and at one time all energy is dissipated in the form of heat. Clear? So if you connect a resistor, you will not find here LC oscillation, or if you find here LC oscillation, at the time the magnitude is slowly decreases, and finally all energy is converting into heat. Clear? So this is all about this question. Clear? Now student, we are going to discuss this question number 7.13, and in this question it is given to you a coil of inductance 0.50 Henry and resistance 100 ohm is connected to a 240 volt 50 Hertz AC supply. Clear? So I can see a coil of inductance means, let's suppose I am drawing here this diagram. Let's suppose this is a coil and a resistance is given to you. Clear? And it is connected to an AC supply. This one is AC supply. Clear? And value is given, this is 240 volt and I can say this is 50 Hertz. Clear? So value of inductance L, this is given to you 0.50 Henry. Clear? And value of resistance, this is given to you 100 ohm. Clear? Now it is connected to a 240 volt and 50 Hertz AC supply. Okay, fine. So what is our objective in this question? Our objective in this question is to find maximum current in the coil and what is time lag between voltage maximum and current maximum. Now listen carefully. First of all, you can see this question is related to LR circuit. Clear? And you know, whenever we have inductor and resistor in a circuit, I can say, let's suppose if I draw here one diagram. In this direction, let's suppose this is voltage across resistance. Definitely we will find current is also in the same direction. Clear? Current is also in same direction. So let's suppose current is also in this same direction. Clear? But you know, magnitude will be less compared to VR. Clear? But what about VL? Definitely I can say, you know very well that whenever we have potential drop across this inductor, so if you see here, voltage always leads. Whenever we are talking about LR circuit, in LR circuit voltage always ahead of 90 degree from this current. Clear? So if I find here net voltage or resultant voltage, clear, I can say resultant voltage is given by this one, and let's suppose I am assuming this is V naught cos of omega t. Clear? And let's suppose I can see this voltage leading by a certain angle phi with this current. Clear? So from here, can I write here expression of I? Yes. So I am writing here general expression of I, and this is given by I naught cos of, important part we have, omega t minus phi. Clear? Because let's suppose if I am assuming, listen carefully, if I am assuming here phase angle that is omega t. Clear? At that time you can say definitely this current is actually lagging behind by an angle phi. So we are having phase angle omega t minus phi. Now what is my objective here? To find maximum current, means first my objective here is to calculate value of I naught. Clear? So how I can calculate here I naught? I can say this is given by V naught by Z. Clear? V naught by Z. So from here you can write like this, V naught divided by, now what is impedance? So if you draw here impedance triangle, clear? Impedance triangle means I can say here, we can say let's suppose in this direction we have resistance and in this direction we have that is XL. Clear? So if you find here value of Z, it can be written like this, under root of R square plus XL square. Clear? So from here we can say value of Z, we can say this is equal to R square plus XL square. Clear? So now first we are going to solve part number A. So from here you can see A part, this is equal to what? I naught, this is given by V naught divided by under root of, I can say R square plus, we can say XL square. Clear? Now what is value of V naught? Clear? In this question it is given, this is actually Vrms. Clear? How can we calculate V naught? We can multiply Vrms with under root of 2. Clear? So we can say 240 under root of 2. So we can write like this, this is 240 under root 2 divided by, I can say under root of R square. Clear? Value of R is given to you 100 ohm. So I can say this is 100 square plus, we can say XL equal to what? Omega L. Omega we can say this is equal to 2 pi f L and this one is square. Clear? So from here you can write like this, 240 under root 2 divided by, I can say this is equal to 10,000 plus, listen carefully, 4 multiply, I can say pi square value is approximately equal to 10 multiply f square. Clear? So frequency is given to you, yes, this is 50 Hertz, so I can say this is 50. So 50 into 50 multiply, now what is value of L? L is given to you, yes, so we can say value of L we have 0.50 Henry. Clear? So 0.50 means I can say 1 by 2 multiply 1 by 2. Clear? Now first we will simplify this calculation. I can say this one and this one cancelled out. Clear? So from here we can write like this. This is 240 under root 2 divided by, I can say, under root of, clear, under root of, this is 10,000 plus this is what, 2500. So 25000. Clear? Clear? Yes. So from here we can say this is 240 into multiply 1.4 divide by under root of 350, it means 350 multiply 100, we can say like this. Clear? When this 100 come out to be square root, we can say this is 10, 10 and 10 cancelled out, and from here you can write like this, 24 multiply 1.4 and this is 350. Now listen carefully. 324 is having a square root that is approximately equal to 18, and I can say 361. For 361 we are having square root for 19. Clear? So definitely this value come out to be between 18 and 19. Clear? So this is equal to 24 1.4 divided by, let's suppose, 18.5. Clear? So from here you can say this one and this one cancelled out. Clear? If you multiply 24 with 14, clear, this will come out to be, we can say 56, we have 5, so 28, so 33 divided by 185. Clear? Now if you multiply 185 with 2, you will find here 370. Clear? Yes or no? 370. So 370 and this one is what? 33.6. So if you multiply it with 8, listen carefully, 8. So 18.5 means you can say 8, we have 64, we have 6, so 14. What I am saying to you, listen carefully. Let's suppose if I write like this, 80, yes. Actually, how can we reduce here calculation? That is very, very important because calculations are lengthy. I can say 336 divided by 185. So if I talk about, if we divide it, clear, it will definitely near about 1.8. Clear? 1.8. Clear? Because 2 times we can say 370. Clear? 10% of this one is we can say 18.5. So 2% is 37. If you add here 37, you will approach near about 370. Clear? So I can say here we are getting this value near about 1.8. Clear? So maximum current that we are getting here, this is 1.8 ampere. Clear to everyone? Yes. Now if I talk about part number B, in this question it is given what is time lag between maximum voltage and current maximum. Clear? So what is meaning of time lag? Time lag means we can say maximum voltage. So I can say we will find here maximum voltage at time t equal to 0. Clear? Yes or no? If you put here 0, you can say V equal to V naught, and you will find current maximum when you are placing here t, this is equal to phi by omega. Listen carefully. If you place here phi by omega cancelled out, phi minus phi is equal to 0. Clear? So whenever we have phi by omega, at that time I can say current is maximum. Clear? Because cos 0 equal to 1. So now we can say what is time lag. Time lag means we can say the difference in the time between these two, we can say V and I, this is equal to what? Phi by omega. Clear? So now we are going to calculate time lag. Clear? Now from here we can say time lag delta t. Clear? This is given by phi by omega. Clear? So omega you can calculate. Omega is given by we can say 2 pi f. Clear? 2, I can say this is 22 by 7. And what about frequency? Clear? So frequency I can say that is 50 Hertz. So this is multiplied with 50. Clear? So from here we can write like this. This is 100, 2200 divided by 7. Clear? So this value we are getting in radian per second. Clear? Now we can say phase difference. Phase difference, how we will find phase difference? That is important. So let's suppose if I again draw here impedance triangle. In impedance triangle, this is R, we can say that is XL, and let's suppose I am saying here in this direction we have this phase that is phi. Clear? So from here we can write like this, tan phi, this is given by XL by R. Clear? What is value of XL? XL is given by omega L divided by R. Clear? What is value of omega we have? This is 22007. So we can say 2200 divided by 7 multiply. What is L? L is given here in this question 0.50 Henry. So I can say that is equal to 1 by 2. And what about R? Clear? R is given in this question. This is 100 ohm. So I can say this is 100. From here you can say this one and this one cancelled out. This is 11. Clear? So now from here we are getting value of 10 pi. This is equal to 11 by 7. Clear? And 11 by 7, it means near about you are getting this value 1.57. Clear? So from here you can say, if you find here this angle phi equal to 10 inverse 1.57. Clear? Now you know at 45 you have value that is 1. Clear? But this is what? 1.57. Clear? So if you calculate, you will find this value. This is equal to 57.5 degree. Clear? Definitely don't worry about these values, because if anytime this type of question will ask in any examination, let's suppose in university examination or other examination, definitely they have to provide here this value, that value of 10 inverse 1.57, this is equal to 57.5. Clear? So this value is in degree. Can we convert it into radian? Yes, we can say we can multiply it with pi by 180. Clear? So now we can say we can find here value of delta t. Delta t, this is given by 57.5 multiply pi by 180 divided by, I can say, omega. Clear? So value of omega we are saying here, this is 2200 divided by 7. Clear? So from here if you solve it, definitely you can get your answer. Clear? So or directly you can solve it. Clear? I am just writing here directly answer, or you can solve it. Clear? From here you can say this is 10. Clear? And actually if we write here this value in terms of pi, definitely our calculation will be very easy. Clear? So concentrate. Let's suppose if I write here like this, value of delta t. Clear? Value of delta t, we can say this is equal to phi by omega. Clear? Value of phi we have, this is 57.5. Clear? And pi by 180. Clear? Divided by, I can say this is 2 pi, and we are having this is 50. Clear? Pi and pi, this one is cancelled out. From here we can say near about, you can say this is near about 1. Clear? Actually we know this is 1 point something, but let's suppose we are taking this is 1. So 1 divided by 2 into 180. Clear? So from here we are getting this value, that is approximately 3.2 into 10 to the power minus 3 second. Clear? So time lag between voltage and current, that is given here near about 3.2 millisecond. Clear to you? So this is all about this question. Hope this question is clear to you. Now dear student, we are going to discuss question number 7.14, and in this question it is given to you, obtain the answer A and B in exercise 7.13 if the circuit is connected to a high frequency supply 240 volt and 10 kilohertz. Hence explain the statement that at a very high frequency an inductor in a circuit nearly amounts to an open circuit. Find how does an inductor behave in a DC circuit after steady state. Clear? Now you can say in example number 7.13, this is given to you as a information. We have connected here inductor and resistance, both are in a series. Value of inductance, that is given to you 0.50 Henry, and value of R we have, this is 100 ohm. Clear? Now it is also given here, it is connected to a supply 240 volt and 10 kilohertz. Clear? So I can say if we talk about frequency, we can write like this, this is 10 multiply 10 to the power 3 hertz. Clear? So from here we can say this is 10 to the power 4 hertz. Clear? Now our objective here is to explain statement that at very high frequency an inductor in a circuit nearly amounts to an open circuit. Clear? So first let us try to find here value of I naught, means maximum current. But before that you can see here we have we can say inductor and resistor. So if we draw here an impedance triangle, you can see let's suppose this is a direction of R. Clear? At the time we can say in this direction we have XL. clear. So if I talk about impedance we can say this is given by Z, and that is equal to XL square plus R square, clear. So let's suppose I am saying this is omega t, clear, or let's suppose I am saying this is representing a sinusoidal voltage, or we can say this variable voltage, this is V equal to V naught cos of omega t, clear. Now we know value of I in the direction of this R, clear. It means I can say I is also in the same direction, because in purely resistive circuit current is in the same phase as voltage, clear. So I can say here we can write like this, I equal to I naught cos of omega t minus phi, clear. So you can see here actually this current is lagging behind by a phase angle phi with voltage, clear. So can we find here value, that is I naught, clear. So I naught means we can say maximum value of current, this is given by V naught upon under root of, why I am saying under root, because we have to write here impedance. So value of Z, that is given by XL square plus R square, clear. So from here I can write like this, value of I naught, clear. Value of I naught, this is equal to V naught. V naught equal to what? This is 240. 240 is VRMS, clear. 240 is VRMS, and I can multiply it with under root 2 divided by under root of XL square plus R square, clear. So under root of XL, XL means I can say this is equal to omega L, clear. So omega L whole square plus I can say R square, value of R we have, this is we can say 100, so this is 10 to the power 4. Now we can see here, if we place here value, this is omega, clear. So we can write here this value, this is equal to 240 under root 2 divided by under root of omega, we can say this is 2 pi f, clear. So I can write like this, this is 4 pi square f square L square plus 10 to the power 4. Now listen carefully, in this question it is given to you, we have high frequency, clear. We have high frequency means this is 10 to the power 4, and what we are doing here, we are doing here square, clear. Value of L is given to you, that is 1 by 2, so this becomes 1 by 4, clear. Pi square, this is equal to 10 and 4. It means you can observe one thing here, this term is actually very large compared to this 10 to the power 4, clear. So now we can say here we can ignore term of resistance, clear. So from here you can write like this, this is given by 240 under root 2 divided by 2 pi f and multiplied with L, clear. So from here we can say this is given by 120 under root 2 divided by pi, I can say value of f, this is equal to 10 to the power 4 and multiplied with 1 by 2, clear. Now we can solve it and we can find here value of I naught, clear. And definitely you can see, if we just observe here magnitude of this current, it will become out to be very small, yes or no. So from here we can say it will be turn out to be small. So directly you can say, because we are using here high frequency current, clear. What we are doing, we are using here a high frequency current. So due to this high frequency current we are getting this value I is very small. It means we can say at high frequency this is actually happening due to inductor. So at high frequency this inductor is actually blocking all the currents. It means I can say it is behaving just like an open circuit, clear. So you can also understand it like this. Let's suppose I am saying this is equal to XL. XL is given by omega L, clear. I can say 2 pi f L, clear. Now in this question it is given we are using a very high frequency source, clear. So when f is very large, I can say this value of XL is very large, clear. So when value of XL is very large, it means I can say this is what we can say, this is inductive reactance, clear. This is inductive reactance. So value of inductive reactance is very high, clear. It means I can say it will offer a more resistance. When it will offer more resistance, I can say the current that will flow, or we can say a very small current will flow, or we can treat this circuit as an open circuit. Clear to everyone? Open circuit, clear? Yes. So one more question is here, how does an inductor behave in a DC circuit after steady state? So let's suppose we just started and this is LR circuit, clear. Let's suppose now instead of AC supply I am providing here a DC supply. So for DC supply I can say value of I is a constant, clear, or we can say if we are talking about DC supply, value of frequency 0, because in DC we will not find number of cycles completed in 1 second, clear. So I can say frequency is 0. So at that time if I am talking about DC, for DC I can say frequency 0, so value of XL, this is equal to omega L, and I can say this is 2 pi FL and this is equal to 0 ohm, clear. So I can say value of XL is given by this is equal to 0 ohm, clear. It means we can say if we are using here DC current, at that time it is just behaving as a conductor wire, it is offering no resistance, clear. Nowadays student we are going to discuss this question number 7.15, and in this question it is given to you a 100 microfarad capacitor is in series with a 40 ohm resistance is connected to a 110 volt and 60 hertz supply. So from here we can say let's suppose I am taking this is capacitor, clear, and this capacitor in series with this resistance, value of this resistance is given to you, this is 40 ohm, clear, and I can say this value we have 100 microfarad, clear, and it is connected with an AC source, and value of this AC source is given 110 volt, and I can say this is 60 hertz, clear. Now from here we can say what is value of maximum current in this circuit, clear. So maximum current in this circuit, clear. So from here you can say, because this is related to RC circuit, for this RC circuit we can draw here impedance triangle. So impedance triangle, how can we draw? Listen carefully. We can say, let's suppose this is direction of R. Now we know for capacitor XC will be in this direction. So if I find here impedance, we can say this is equal to R square plus XC square, clear. Now from here we can say definitely here we are having some phase difference, or we can say there is some angle between this one and this one. Now we know we always find current in the direction of this R, clear. So from here we can say let's suppose if I am drawing here, this is direction of I also, clear. Now so from here you can say, let's suppose we are talking about input voltage. Input voltage is given by V equal to V naught cos of omega t, clear. Now we know in capacitor in this circuit, that is RC circuit, in RC circuit we always find current is leading, or we can say current is leading with from voltage, clear, or you can say voltage is always lagging behind, clear. Voltage is always lagging behind. So voltage, you can see if you draw here impedance triangle for voltage, you can also draw it, clear. This is impedance triangle. Impedance triangle is actually relates the resistance of each component, clear. Now we can also draw it like this. Let's suppose in this direction it is representing VR, in this direction this is representing VC, I can say this is resultant, clear. So this is representing resultant, and value of this resultant, this is given by V equal to V naught cos of omega t, clear. So now from here can we write here value of I? Yes, I value we can say it is given by I naught cos of omega t plus phi, clear. Now what is my objective in this question? My objective here is to calculate value of I naught, clear. So how can I calculate here? So I can say value of I naught, this is given by V naught divided by under root of R square plus XC square, clear. First we can calculate here value of XC. Yes, value of XC, this is given by 1 upon omega C. I can say this is equal to 2 pi F. F is given to you, this is 60 hertz, clear, and I can say multiplied with C, value of capacitance. So it is given to you, this is 100 microfarad. So 100 into 10 to the power minus 4, clear. So from here we can say value of XC, this is given by, this is 100 multiplied 10 to the power minus 6, 100 microfarad, so this is 10 to the power minus 6, clear. So directly you can say here we are getting in numerator 10 to the power 4, clear, and it is divided by 2 pi multiply 6 divided by 10. So I can say this is equal to 10 to the power 3, clear. So from here you can write like this, this is 1000 divided by, this is we can say 12 pi, clear. So from here we can say this is 1000 divided by 12 multiply 3.14, and I can say this is equal to 1000 divided by, we can say this is 8, we have 4, so this is 16, we have 1, so 37, near about we are getting 38. Clear? Now from here we can say, if you write here value of XC, clear, you can actually first write like this, this is 1000 divided by 12 pi only. Clear? So this is value of XC. Clear? You can calculate it, no problem, and you will find this value in ohm. So we are getting this value near about, I can say 27, near about. Clear? Now if I place here this value in this term, I can say value of V naught. Clear? So value of V, it is given to you in this question, that is 110, but this is RMS value. So I can write like this, 110 under root 2 divided by, this is under root of R square. R means I can say this is 40. So I can say 40 square plus this is 27 square. Clear? Yes or no? Or you can say this is correct. This is 27. Clear? And what about value of R? Yes, that is 40. Clear? Clear? So we are getting this value. Clear? Yes. So now if you say, can we write like this? This is this one upon under root of 1600 plus what is square of 27. Clear? Directly you can say, if you are finding here 27 square, 27, I can say that is 49. Clear? Here we have 14, this is 28 and divide by 4. So 9 we can say 2 and we have 1, 729. Clear? So I can say this value we have 729. Clear? And this is given by 110 under root 2 divided by under root of 110 under root 2, it is divided by 9, 2, I can say this is 3 and this is 2329. Clear? 2329. Clear to everyone? Now what is square root of this one? Now you can say 2500 square root we have near about 50. So definitely it will be below some 50. Yes or no? So from here we can say near about I am taking this value 110 under root 2 divided by 48. Clear? 48. Now we can say if you solve it, now if you solve it, you will find exact value near about 3.24 ampere. Clear? Near about. Clear? So this is value of maximum current that we can obtain in this question. Clear? Yes. Now second part is here, what is time lag between current maximum and voltage maximum. Clear? So from this impedance triangle you can say, let's suppose this is phi. Clear? So can we find here value of 10 phi? Yes. So directly we can say 10 phi. 10 phi is given by, that is XC by R, or we can say this is equal to omega C R. Clear? So if I place here value of omega C and R, we can get here value of 10 phi. Clear? So from here I am writing here. Clear? So I can say value of 10 phi, this is given by 1 upon omega C R. Clear? 1 upon omega. Omega is given to you, this is 2 pi F. Clear? Multiply C multiply R. Clear? And it is given by 1 upon 2 pi. Value of F. F is here, this is 60 Hertz. Clear? So 60 Hertz, and I can say 100 microfarad. So 100 into 10 to the power minus 6 multiply. What about value of resistance? Value of resistance we have, this is 40. Clear? So now from here we can say 10 phi value. If you solve it, clear? Definitely you can solve it. It's not a difficult task. Directly we can say here we have 12 pi. This is 1000. We can say that is 10 to the power 4. So multiply 10 to the power minus 2 and multiply it with 4. Clear? So from here we can write, say this is equal to 100 divided by 12 pi multiply 4, or we can say this is 25. So 25 divided by 12 pi. Clear? Near about you can say you are getting here, this is near about 2. So 2 divided by 3.14. Clear? 2 divided by 3.14. So I can say here you will get answer. If you calculate, definitely without calculating you cannot solve this value of 10 phi. Clear? But I am telling you direct value of 10 phi. Clear? Yes. Now from here I can say value of 10 phi. Value of 10 phi that you will get here. Clear? You will get here value of 10 phi. This is 0.663. Yes. Clear? If you calculate, definitely you will find this value. So from here we can say value of phi, we can write like this, 10 inverse 0.6631. Clear? Now from where we will get this value of 10 inverse? Definitely from calculator, because we don't know, this is not a general value. Clear? And this is not a standard value from where we are getting this value, but I am saying to you, you can take here some approximation. Clear? Now you know, if we write here 10 inverse 1, that is 45. If we write here 10 inverse 1 by root 3, that is 1 upon 1.73, so near about you can say 0.5. So definitely it will be more than 30 degree and it will be less than 45. Clear? It means this value you will get here, this is equal to near about 33.5 degree. Clear? So from here we can find here time lag, or we can say delta t, time lag. Time lag is what? Listen carefully. Time lag is actually given by this one. Now let's suppose if I put here value of t, that is equal to minus 5 by omega. At that time I can say here we are getting maximum value of current, or we can say we are getting this angle 0. Clear? It means I can say, if we talk about this expression V equal to V naught cos of omega t, here we put t equal to 0, and here if we put here t equal to, when we will get this angle 0, this angle we will get 0 when t equal to minus 5 by omega. Clear? So here you can say value of time lag, that is given by 5 by omega. Clear? Now from here we can say value of phi, it means 33.5 degree and multiplied with pi by 180 and multiplied omega. Clear? Omega means, I can say omega means what? That is 2 pi f. From here we can say pi and pi, this one is cancelled out. Clear? So value of delta t, we are getting 33.5 divided by we can say this is 360 multiplied value of f. Clear? Value of f we have, this is 60 hertz. Clear? So if you solve it, definitely you can say this is 335 and this is 360, near about 10 you are getting. Clear? So I can say near about 1 by 10 multiply 60. Clear? So from here we can say, if you solve it, you will find here near about answer 1.55 millisecond. Clear? So calculation is definitely tedious in this question, and if you find such type of question in any competitive examination, no, you will find any question in competitive examination, it will be like this. You can easily solve that question, you will get a perfect value, and if anywhere, if data is needed, they will provide to you in a question. Clear? So this is all about this question. Clear to everyone? Now dear student, we are going to discuss this question number 7.16, and in this question it is given to you, obtain the answer to A and B in exercise 7.15 if the circuit is connected to a 110 volt and 12 kilohertz supply. Clear? So I already draw here this diagram that you have already seen, and input supply voltage is given 110 volt and this is 12 kilohertz. Clear? It is also given here, explain the statement that a capacitor in a conductor, capacitor is a conductor at a very high frequency. Clear? So now we can see, actually we know, if we calculate here value of I naught, clear? I naught, this is given by V naught divided by, now you know, here we will write here value of Z. Clear? So value of Z, this is given by under root of, I can say R square plus XC whole square. Clear? Value of V naught you know very well, that is 110 multiply under root 2 divided by under root of R square. R means I can say 40 square plus what about XC. Clear? So if I calculate here value XC, this is given by 1 upon omega C. Clear? And we can say this is equal to 1 upon 2 pi. Clear? XC equal to what? This is given by 1 upon omega C, and 1 upon omega C, this is equal to what? 1 upon 2 pi, and F is given to you, this is 12 into 10 to the power 3 divided by, clear, 2 pi into 12 into 10 to the power 3, and what about C? I can say 100 into 10 to the power minus 6. Clear? So from here I can say this is equal to 1 upon, I can say 24 pi, clear, 24 pi into 10 to the power 5 multiply 10 to the power minus 6. Clear? Yes or no? So from here we can see this is given by 1 upon 24 pi, clear, and multiply 10 to the power minus 1. Clear? So now if you write here we can say this is 10 divide by 24 pi whole square. Clear? So from here we can say 24 multiply 3.14. So near about 72 we are getting. Clear? And we can say this is what, 0.1 something. Clear? So from here we are getting this value 110 under root 2 divided by under root of, I can say 40 square plus this is 0. I can say this is 0.133, let's suppose. Clear? And that is whole square. Now you can say here value of this 0.133, this is very less compared to this 40 square. Clear? It means we are neglecting that value. Clear? So from here you can say we are getting maximum value of current 110 under root 2 divided by 40. Clear? So value of I naught we are getting 110 under root 2 divided by 40. Clear? We can say this one and this one cancel out. So 11 by 4 multiply under root 2. So 11 by 4, 1.414. Clear? So from here we can write like this. This is 11 by 4 into 1.414. So let's suppose this is 1.4 only. So we have 4 and I can say here we have 4. So 15.4 divided by 4. So now if you calculate it, you will find here this is 3 point. We have here 3. Clear? So near about 8. So 3.8 ampere. So maximum current that we are getting in this circuit, this is 3.8 ampere. Clear? Yes sir. Now you can say let's suppose if we neglect here this capacitor, because you are neglecting here resistance that is offered by capacitor. Clear? So it means we can say at a very high frequency. Clear? What is given in this question? Frequency is very high. Clear? So at a frequency of very high frequency, if we are talking about high frequency, at that time you can say this capacitor behaves just like a straight wire. Clear? Or it is just behaving like a conductor. It is offering a very little resistance or very less resistance. Clear? It means I can say at high frequency, clear, what is happening? At high frequency current, at high frequency what is happening? We can see this capacitor, at high frequency capacitor behaving as a conductor, having a very low resistance, Clear? Yes. Clear? So at high frequency capacitor behaving as a conductor having a very low resistance. Clear? So this is all about current. Clear? Yes. Actually you can also find here that is phase difference. Clear? If we talk about phase difference, you can see 10 phi. This is given by, I can say that is Xc by R. Clear? Value of Xc, this is equal to 1 upon omega c multiply R. Clear? Omega, I can say value of omega, you can say 2 pi f. F we have 12 kilohertz. Clear? Capacitance value we have 100 microfarad, 100 into 10 to the power minus 6. Clear? And what about value of R? Clear? Resistance, that is 40 ohm. Clear? So from here you can say this is 10 to the power 3, this is 10 to the power 5, this is 10 to the power 6, this one all are cancelled out. Clear? From here we can say this is equal to 24 pi multiply, is there something? Yes, that is 4. Clear? So near about you can say here this is 24 multiply 4, 96. So 1 upon 96 multiply 3.14. Now you can say here you are getting a very less resistance. Clear? And you can say here near about you are getting this value 0, near about. Clear? Or you are getting a very less value. Clear? So I am saying not 0, directly we can say this value we are getting 0.00, let's suppose 1 something. Clear? It means I can say value of phi that we are getting, this is equal to 10 inverse 0.001 something. Clear? It means I am saying here value of phi, this is near about 0. Clear? It means what you are understanding by this definition or by this angle. Actually we are understanding here the resultant is making a very less angle with resistance. Clear? Or we can say value of Xc is very low. Clear? So like this you can prove at high frequency capacitor behaves just like a conductor that is having very less resistance or negligible resistance. Clear? So this is all about this question. Dear student, we have one more question in this particular question. It is given here, when you know Xc, that is given by 1 upon omega c. This is given by 1 upon 2 pi fc. Clear? Now, whenever we have a DC current, whenever we are talking about DC current, so for DC current I can say frequency this is equal to 0. Clear? So for DC we have value of f, that is 0. So from here we can say this is given by 1 upon 0 and near about infinity. Clear? So I can say we are getting here this value near about infinite. Clear? So I can say if we are talking about capacitor, if we connect capacitor in a circuit where a steady current is flowing, at that time this capacitor actually behaves just like an open circuit of a open circuit. Clear? Or you can say it will not allow DC current to pass through it. Clear? So this is all about this question.